Hello. This video is over Chapter 34, the alternating series test. So again, I'm assuming that you have read definition 215 of what an alternating series is and theorem 216, which is the alternating series test. So now I'm going to look at two examples. One is in the notes, example 217, and the other one is not. The reason I'm going to give you both of these examples is I want to demonstrate that the alternating series test will only tell you if a series is convergent if the limit of the terms is 0. It will not tell you if it is absolutely convergent or conditionally convergent. The alternating series test will only tell you if a series is convergent. So here, we've already seen from the last chapter that the alternating harmonic series is convergent, but now if we want to apply the alternating series test, we simply take the limit as n tends to infinity of 1 over n, and we see that that is 0. So, therefore, the series that we were given converges by the alternating series test. So this series converges by the alternating series test. This series here also converges by the alternating series test. Since the limit as n goes to infinity of 1 divided by n squared is equal to 0, this series n equal 1 to infinity of 1 divided by n squared converges by the alternating series test. Now, recall that this series is actually absolutely convergent because the series n equal 1 to infinity of 1 over n squared is pi squared over 6. I'm cheating a little bit. I didn't actually prove to you that this series converges to pi squared over 6. I just showed you that pi squared over 6 was a very good estimate. But it does converge to pi squared over 6. But this series converges by the alternating series test, but it's actually absolutely convergent. The first series, in example 217, this series also converges by the alternating series test, but it's conditionally convergent and it's not absolutely convergent. Why am I telling you this? Because students will often say that something is absolutely convergent by the alternating series test. Series are not absolutely convergent by the alternating series test. They're convergent by the alternating series test. They may or may not be absolutely convergent. But the alternating series test doesn't tell you if something's absolutely convergent or conditionally convergent, just that it's convergent. Likewise, you can't say that something's conditionally convergent by the absolute or by the alternating series test. So that will conclude the video on Chapter 34.